Hello, here I will solve some problems from chapter 7.4, Algebra and the Trigonometric Functions. This section begins on page 501. So again, sine squared theta plus cosine squared theta equals 1. That's an identity that I covered earlier. Notice this is an equation, so whatever you do to one side of the equation, you have to do to the other side of the equation. And if you want, you can subtract, you can divide everything. You can divide everything by cosine. So if I divide this by cosine squared theta, okay, so if I divide everything by cosine squared theta, sine over cosine is tangent, cosine over cosine is 1, and 1 over cosine is secant. Additionally, if you want, you can divide everything by sine squared theta. Okay, so sine squared theta divided by sine squared theta is 1. Cosine divided by sine is cotangent, and 1 divided by sine is cosecant. So this is another identity. Okay, so let's go to solving some problems from page 507. So for numbers 1 through 12, it says carry out the indicated operations or simplify. So here I see, we don't exactly know what sine of theta is, but we can call that a variable, like maybe y. We don't know what cosine is, so maybe we call this a variable, call this x. So we have 10, if you want to see it like this, we have 10xy plus 4xy minus 6xy. Combine the coefficients. So 10 plus 4 is 14 minus 6. This will be negative 2 sine theta cosine theta. Okay. This one here, again, that sine theta, we can treat that as a variable. Cosine theta, we can treat that as a variable. So there's no adding or subtracting going on in these parentheses. So I can just square 2 square sine square cosine and then subtract this. So this will be 4 times sine squared times cosine squared. Let me write this out. So we have 4 of this unknown minus 1 of the exact same unknown. Cosine squared times sine squared is the same thing as sine squared times cosine squared. And so 4 minus 1 is 3. This idea is like 3 times 4 is 4 times 3. Number 6, 3 minus 2 tangent theta all being squared. Okay, so if you're to use the binomial theorem, we're squaring it. So let's square the first. We have 9. And then we have minus 6 minus 6. That's minus 12. This is tangent. And then plus 4 tangent squared. So this is the same thing as so that 3 times 3 is 9, and then 3 times 2 is negative 6, minus 6 gives me the negative 12, and then negative 2 times negative 2 is positive 4, tangent times tangent is tangent squared. The numbers are good, it's kind of squished. Let me rewrite this. Okay. Number 8, this is a difference of squares. And so square the first term and then subtract the square of the second term. Number 9. So this is a pattern. I see a -1 in all of this, and let me show you what I mean by that. So the numerator, we can factor a -1 out. Because -1 times 2 tangent is -2 tangent. -1 times -5 is +5. And in the denominator, and I like to put a multiplicative 1 wherever possible. It's just too many times when students simplify this, if there's nothing in the denominator, they think there's a 0. And then when you have a 0 in the denominator, it is undefined. That's not the case here. There is a 1. -1 over +1 gives you -1. 1 over sine A minus 3 over cosine A. Okay. To add or subtract fractions, you need the same denominator. So this is missing a cosine A over cosine A. This one is missing a sine A over sine A. So that I'm multiplying this one by a value of 1, the same non-zero number divided by itself, not changing anything. Multiplying this also by a 1, that's not changing anything. And what this gives me is cosine A minus 3 sine A, all divided by sine A cosine A. Okay. Numbers 13 through 18. So this says factor each expression. Okay. So we're going to factor this. Well, let's factor by the AC method. Factor this by grouping. You could also factor this by the quadratic formula if you like. We have an unknown amount being squared, the exact same unknown amount to the first power. This is quadratic in form if I were to set this equal to 0. But the AC method, you want the product of A times C, -24, and then you're going to find the binary factors that add up, or the binary factors that sum up to your B value. In this case, they're adding, but it might be subtracting. So we have -24, and I want to add up to a +2. And so this is, well, we have 6 times 4 is 24. And let's go with a +6 and a -4. Because 6 times -4 is -24, and 6 minus 4 is 2. So we can rewrite this as okay. So that these two are the same equation. 2 is the same thing as -4 plus 6. The -4 plus 6 is +2. Then parentheses, take out the greatest common factor. So this greatest common factor is secant theta. I'm sorry, secant beta. And then these two should match. If they don't match, then you've done something wrong up in here with the AC part. So the greatest common factor here is going to be a +2. And then pull out the next greatest common factor. When you pull that out, what you're left with behind is that. And since this never was actually equal to 0, we cannot actually solve it. But this is the factored form of what you started with. Okay, this one here, 16 and 9 are relatively prime. That means they don't have anything common except for a 1. 16 is a bunch of 2s, 2 to the 4th power, and 9 is a couple of 3s, 3 times 3. So they don't have anything common. We can take out a sine squared. When you take out a sine squared, what you're left behind with is 16 sine beta minus 9. And I'm going to leave it at that. Technically, everything is a difference of squares, and so technically I could factor this as well. But I think it would be more complicated looking. This is fine. Number 18, let's factor this. So I see I have a 5, a common 5, and I have a single cosecant cotangent in both of these. So take out the common 5, the cosecant of b, cotangent of b. When I take that out, what I'm left with is cosecant b, cotangent b minus 3. Yeah, that's all we can do with that one. The 19 through 32. So these are right in terms of sine and cosine and simplify each expression. Okay. So here I have a difference of squares. So this is that's the numerator with our denominator. But this is also a difference of squares. So we can keep factoring this. And looking at the similarities between these two, I just have the subtraction in the wrong direction. So in the denominator, let's factor a -1 out of that. When I do this, I have sine A minus cosine A. Because -1 times sine is negative sine, -1 times negative cosine is positive cosine. So that now these two terms are the same, it can get simplified. When you're dividing something by -1, I'm going to put this -1 into the numerator just to clean this up a little bit. And this gives me negative times okay. Factoring this out, so what this is sine theta over 1 times 1 over sine theta times sine theta divided by cosine theta. Okay, so that now these simplify out. Tangent's coming along for the ride, so this ends up being tangent of theta. Okay, let's factor the top, and the denominator is a difference of squares. So the numerator, take a 3 out. and the denominator okay, and now these are the same. So we have I'm not going to convert this into any form of cosecant because we're subtracting 2. I think this will be about as simple as that problem gets. All right. Thank you very much. Please go to tutoring.